We began by discussing the nature of quantum superposition, where multiple potential outcomes of a quantum event exist simultaneously. This idea led to an exploration of the concept of wave function collapse, where, once an observation or measurement is made, the quantum system collapses into one of the possible states. A pivotal aspect of this discussion was the notion that observer-dependent collapse plays a crucial role in determining the outcome of quantum events. This concept suggested that consciousness or perception could influence the state of quantum systems. We then explored the nature of time and space from the perspective of different species, starting with a simple example: the housefly. The housefly perceives time 240 times faster than a human, which means its experience of the same quantum event, the collapse of superposition, occurs differently for it than it does for a human. This led to the idea that the collapse of the quantum wave function can differ from observer to observer depending on their perceptual framework. The collapse, while occurring within the same quantum reality, happens at different moments and might result in radically different perceptions of the same event. Thus, we suggested that two different collapses could occur for two observers, e.g., a human and a fly, even though the event happens in a single, shared reality. As we continued to develop this idea, we extended it to multiverse theory, where different observers, say hypothetical alien species or entirely different creatures, might collapse quantum superpositions in ways distinct from human experiences. These species, with their own sensory capabilities, could have entirely different laws of perception that shape the reality they experience. This brings forth the idea that parallel universes could exist with distinct physical laws, giving rise to different types of beings whose sensory experiences shape their realities. Next, we introduced the idea of systemic order in chaotic patterns observed across different scales, from the Planck scale to cosmic structures. The geometrical distribution of energy in nature, present in both tiny particles and massive galaxies, serves as evidence of an intrinsic organizational pattern. This pattern is not just observable in the physical world, but also mirrors the organization of human perception and the collapse of quantum states. Our three-dimensional reality is thus a product of these patterns, and it defines the limits of how we perceive the universe. In a way, the boundaries of our reality are shaped by our sensory and cognitive structures, which are in turn influenced by the collapse of superposition as we experience it. At this point, we introduced a deeper layer by considering how the perception of time and space in different creatures, such as the mantis shrimp, could lead to radically different interpretations of the same event. The mantis shrimp's vision and temporal perception are vastly different from that of humans, allowing it to experience and respond to events in ways that humans cannot fully comprehend. This insight added a fascinating twist. Creatures with different sensory capabilities might experience the collapse of superposition in ways that further diverge from the human experience. We then transitioned to the idea that human reality, shaped by three-dimensional perception, is inherently restrictive compared to potential realities of other creatures, whether hypothetical or real. These creatures might perceive and interact with the universe in ways far beyond our understanding. One particularly intriguing possibility we entertained was the idea of a four-dimensional creature, such as an octopus, whose ability to navigate spaces and solve problems in seemingly impossible ways suggests it might be tapping into a higher dimensional awareness, even if in subtle ways. Next, we raised a profound question about how the speed of light might be perceived differently by creatures with radically different perceptions of time. This led us to the idea of parallel universes, where creatures might live under different physical laws, and their unique perceptions might give rise to realities quite distinct from ours. We posited that the collapse of quantum superposition in parallel universes could yield radically different outcomes, even for the same quantum event. Finally, we examined the creation of our universe through the lens of human perception. Perhaps our sensory capabilities have not only shaped our experience of reality, but also played a fundamental role in the collapse of quantum states, giving rise to the unique laws and constants of our universe. Our perception, bounded by the limitations of our three-dimensional existence, has shaped a reality that we cannot fully escape or transcend. This might explain why we have yet to encounter life forms beyond Earth. They might exist in ways we cannot yet perceive or comprehend. Here, we introduced an important point. The apparatus used to measure quantum states is itself a creation of three-dimensional beings, humans. These measuring instruments, being bound by the same limitations as their creators, can only observe quantum events from within the confines of three-dimensional reality. Therefore, even when we use tools to observe quantum superposition, the way in which we measure and collapse quantum states is inherently shaped by our three-dimensional understanding. These devices are not objective or fully neutral observers. They are products of our sensory and cognitive frameworks. This insight suggests that deterministic collapse, as seen in quantum experiments, may be influenced not only by the observation itself, but also by the inherent limitations of the instruments and observers.